we would like to present AR2-D2, training a robot without a robot. AR2-D2. AR2-D2 is a robot demonstrations framework in the form of an iOS app that people can use to project an AR robot into the physical world and record a video of themselves manipulating any object whilst simultaneously capturing the essential data modalities for training a real robot. With the advances in robotics, we are getting near to have our own personalized robot that can perform a wide range of tasks in our own homes. A lot amount of effort in robot learning focuses primarily on offline learning from demonstrations, and over the years it has shown great result in learning multitasks. However, the bottleneck to these methods is in data, specifically in collecting robot demonstration data with a physical robot with a diverse list of objects in custom environment. There are a lot of efforts in developing new methods, tools and approach in collecting better demonstrations and larger scale. However, all of these approach requires either a physical robot or building a simulation of the physical world before the data could be learnt and deploy into the real-world robot. Our system allows user to use their iPad or iPhone with depth sensor to project an AR robot, and by tracking the movement and pose of their hands, the system would collect important data such as RGB, depth, and key pose of the user hand. These data can then be used to train and deploy in real robotic system. This is a demonstration of our AR2-D2 mobile application interface. The system projects a AR robot into the physical world, and the robot follows the human hand pose, and the user's finger controls the closing and opening of the gripper. All of the visual data and hand pose data are being captured for later use in training. With the collected data, we employ a few tricks in computer vision to generate visual-based data for training visuomotor policy and also 3D voxelized representation to train VC such as per act. We collect AR2-D2 demonstrations on a set of personalized objects, and demonstrate that a policy trained on this data executes on a real Franca Panda robot. We gather demonstrations centered around 3 common robotics tasks: press, push, pick up. For each task, we collect 5 demonstrations using 3 different objects, which vary in color, size, geometry, texture, and even functionality. We train an individual agent for each task. We train an agent for 30K iterations per set of demonstrations. We then freeze the backbone of the perceiver actor architecture and fine-tune the rest using the set of VR. Using HTC Hive, demonstrations on dummy objects. This fine-tuning process spans an additional 3K iterations, equivalent to approximately 10 minutes of wall clock training. Fine-tuning allows us to close the domain gap resulting from differences in depth cameras between the Kinect V2 used by perceiver actor and the iPhone, iPad depth camera used by AR2-D2. We evaluate the trained policy's ability to manipulate personalized objects in the real world. We present our experimental setup in 3 key takeaways. First, we validate that AR2-D2's demonstrations can train a real robot to manipulate personalized objects without access to a physical robot. Second, the agent trained using AR2-D2's demonstrations perform on par with training on real robot demonstrations. Third, AR2-D2's demonstrations can enable learning policies from both image as well as voxelized inputs. From our experiments, we show that AR2-D2 demonstrations yields useful representation for training a real robot, and AR2-D2 demonstrations train policies as accurately as demonstrations collected from real robots. From our ablation studies, we also found that fine-tuning with 5 demonstrations and for 3,000 iterations yield the optimal result, and the data collected from AR2-D2 can support image-based behavior cloning policies and also policies that takes 3D representation as training data. For the 6D task in the ablation studies, we did not fine-tune the AR data, and it was achieved with 0 shot with a fixed camera offset. Moreover, our user study indicates that users find AR2-D2 intuitive to use and require no training compared to 5 other collection methods. Users also produce demonstrations as fast as kinesthetic teaching.